Definition of a density curve is there are no negative y values. In other words, there's nothing on the y-axis that goes below the x-axis. And the second part is that the area underneath the curve has to total 1. So let's go ahead and find the area of this curve by breaking it down into little chunks that we're familiar with. So we'll break it down into rectangles and triangles. Let's find the rectangle area first. Those are the easiest. It's just height times width. So the width of this is 3 minus 2, so it's 1 on the base, and 0.25. So this rectangle is going to be 0.25. That's going to be 0.25. That's going to be 0.25. And the area formula for a triangle is 1/2 the base times the height. So it's 1 times 0.25 divided by 2, but then there's 2 of them, so we're going to multiply them by 2. So yes, the area underneath this curve is 1, so therefore it is a density curve. But there are other ways to do this. Instead of making the units of measurement on the y-axis or the x-axis to fit 1, you can just go ahead and take any curve that doesn't have any negative values on the y and just sum up the area and make that 100%. That way, that makes this a density curve, this a density curve, this a density curve. There, practically everything is a density curve. So example, if you wanted to find out what percent of the random variables fell between 0.6 and 0.8, you would take this area of the pink one. It would be 100 height times 0.2. That would be your numerator, and then you would have to sum up the area of each one of these rectangles, add them all together. That would be your denominator. That turns it into a density curve. That's all you have to do for that. Now these lead up to this guy, the normal distribution curve. That's what you're going to be using a lot in statistics. So here's a basic one, and then after you take all your data and standardize it, you get this, and this is where all the magic begins. So that is what a density curve is. It gives you a